Today we're going to analyze options data in Python. In particular, we're going to look out for unusual trading volume with a focus on extended trading hours, so not in the regular trading hours, or also on unusual ratios between trading volume and open interest. This video is going to be super interesting for anyone in finance who wants to learn more about programming, or for anyone in programming who wants to learn more about finance. If you like this video, let me know by hitting a like button and subscribing, but now let us get right into it. Alright, so we're going to analyze options data in this video today, and we're going to write a lot of code that looks like this. So this is my prepared code, just giving you a little preview. So this video has two main target audiences. One is people in finance that want to learn more about data manipulation, data analysis, data visualization with Python. And the second one is people that are already into data science and they want to apply this to some new sort of data. So for example, to financial data. So you can apply your Pandas skills, your Matplotlib skills, your NumPy skills to data that is related to finance, in this case options data. Now there's no data analysis without data, and especially in the finance world, the data that you need is usually not just open source. You have to use some API that provides you with the data, and in this video today we're going to use Theta data. So this is what we're going to use to get the data that we need onto our system, and they are also the sponsor of this video today. So you will find a link to them in the description down below. What we're going to use is their terminal. You can go to the docs here, V3 docs, and you can see what they have to offer. You don't have to do that. I'm going to cover this in this video already. But of course, if you want to take a look at this yourself, you can just go down here in the docs to REST API, to options, and then you can take a look at the different endpoints for historical data, for snapshot data, for listing what's out there. So what dates do we have, what ticker symbols, what expiration dates, and so on. You can take a look at this yourself as well. So let us now move on to the setup. The Theta Data Terminal is a Java application. So you need to go to thetadata.net, then to downloads, version 3 terminal. This is then going to ask you where you want to save it. I'm going to save it in my tutorial directory, this jar file here. So make sure you have that. Second, you also need Java on your system. I'm not going to go through the full installation process. If you don't have Java, you have to go and download Java. So just go to java.com and then to the download section. You can download it for Windows, Mac, or Linux. If you are using Linux, I recommend to look if you have Java in your package manager. On Arch, for example, you have a package for Java, to be precise, for the OpenJDK or Java runtime environment. Just get Java onto your system. I'm sure you can figure out how to do that. You will find for Windows and Mac the installers on this page. If you're using Linux, probably you know how to install Java. And once you have all of this, you can go open up a terminal, navigate to the directory where you have your jar file downloaded, and you just have to say java-jar and then theta data terminal, or theta terminal, sorry, .jar. So you just run this command, and this is going to ask for your credentials. So you need to have a Theta Data account. You need to go to the website, create an account. You need to authenticate yourself. In my case, I have the accounts at Neural9 email, and then also my password here. And once I'm successfully authenticated, I can just use this terminal on localhost. So I can get the data that I need by sending requests to localhost. To be precise here, to localhost port 25,503. So I'm going to move this now to a different screen. I'm going to open up another terminal, and now we're going to set up the development environment. So I'm going to zoom in here a little bit. We're going to go to the tutorial directory again. And in here now you have to set up your Python project. So how exactly you do that is up to you. The simplest way is to just use pip to install the packages on your system. So pip or pip3 install, and then the packages that we're going to need. So for example, pandas and NumPy and Matplotlib. What I'm going to do here is I'm going to use UV. So if you also want to use UV, what you have to do is you have to say pip or pip3 install UV. And then instead of doing pip, you can just do UV init to create a project. And then you can say UV add to add the packages. You don't need to do that if you think that's too complicated. If you don't want to use UV, just go ahead, and whenever I do UV add, you can do pip or pip3 install in the packages. So in my case though, I'm going to say UV add, and I'm going to install pandas, I'm going to install NumPy, I'm going to install Matplotlib, I'm going to install HTTPX, which is just for sending requests to Theta data, and I think that's basically it. So we're going to load this. Now one more thing actually that we also need, since we're going to work now in an interactive Python notebook environment, so we're not going to just run single Python files, we're going to work in this interactive environment, we're also going to install JupyterLab. So in my case, UV add JupyterLab as one term, so JupyterLab written together like this. And then once we have this, just UV run Jupyter, and now we want to have a space in between lab. Now, if you're not using UV, what you do is you just say Jupyter Lab without UV run. So running this will open the instance. It will also open up a web browser. So it will automatically go to localhost. And if you're just having one instance running, it's going to go to port 8888. In my case, I have 2 instances running, so it goes to 8889. So I can also move away this terminal to a different screen. And now all we have to do here is we have to create an IPython notebook. Just click on the Python logo and now you have a Jupyter notebook running on your system. We can zoom in here. I can save this as main IPYNB. And here now, for those of you who have never worked with such an interactive environment, what we can do here is we can write Python code and execute it cell by cell. So I can say x is equal to 10. Then I can run this cell. I can say print x in a different cell. And I can now say x is equal to 20. And I can run this cell again, even though it's before this in the code. Then I can run this cell again, and this cell. I can just do it in a modular way. I don't have to run all of the code from top to bottom every time I want to change something. So that's enough for the basics. Let's start with the imports now. I'm going to import from core Python IO. I'm going to also import datetime as DT. Then we're going to import NumPy as NP. We're going to import pandas as PD. We're going to import matplotlib.pyplot as PLT. And also we're going to import HTTPX. Now, very briefly, what are we going to do with these? We're going to use IO mainly in combination with HTTPX to get a input-output object so we can convert the response from theta data into a pandas data frame. We're going to use pandas data frames to do data manipulation and data analysis. We're going to use NumPy just for some basic X value generation when we do plotting. And we're going to use matplotlib for the visualizations, for the charts. So what we need now is data that we can analyze. And we're going to get this data from theta data from the terminal that is running on localhost. And to understand how we interact with it, we can go to the documentation of theta data. So we can go to the website, we can go to docs, version 3 docs, then we can go to REST API, option. I'm going to work with historical data, so we're going to go to history. And here we have a bunch of endpoints that we can look at. Now, our goal is to look at unusual trading volume outside of the regular trading hours. These are from 9:30 a.m. to 4 p.m. Eastern time. This is when the market is open, and we're interested in unusual volume, unusual trading happening outside of these hours. So in the pre-market and in the after hours, or in the extended trading hours. So all we need is an endpoint that gives us volume. And one of these endpoints is the open, high, low, close endpoint. So open, high, low, close means opening price 9:30, closing price 4 p.m. High and low basically means the maximum and the minimum during the regular trading hours. And here you can see what we have to submit in the request, but down below you can also see what we get as a response. And one of the fields here is volume. So what we have to provide here is the date, the particular day that we're interested in. We need to provide the underlying asset, so the symbol, the ticker symbol of the stock or the index, then the expiration date. So this is when the option actually expires. And we can of course have the same asset on the same date trading with multiple different expiration dates. So this is an important field. Then we also have the interval. So how granular do we want the data to be? I'm going to focus here on minute data. So every minute I want to have a new entry. And then we can provide the time frame. The default here, as you can see, are the regular trading hours. So 9:30 to 16, we want to have from the very beginning to the very end. So from 0 to 23:59:59. Now, this data where we have some activity outside of the trading hours, the regular trading hours, is only going to be possible to get here for indexes. So we're not going to get this for Apple stock. We're only going to be able to get this for something like NASDAQ or SPX, so S&P 500. Now, one thing that's very convenient here in the theta data documentation is that when we scroll down, we can find some sample code. So I can just copy this. I can paste this into my notebook. And when I run this, I will get some data, open, high, low, close data for the Apple options that have an expiration date, which is January 17th, 2025, and at the date November 7th, 2024, with an interval of 1 minute. So now here I get all the data streamed, but this is not how we're going to use this. We are going to actually take this data and transform it into a pandas data frame. Most of this code can stay as it is, but we're going to replace this here with httpx.client. Timeout can stay at 60 as client. And then we're just going to say response is equal to client.get URL and the parameters are going to be the parameters, and we're going to raise for status, and that is basically it. Then we're going to take this result and we're going to feed it into a pandas data frame. So I'm going to say here data frame is equal to pd.readCSV, and now we need our string IO. So I'm going to say IO string IO just response.text. So that is going to turn it into a data frame. I can run this now. And when I look at the data frame, we now have the same data as a pandas data frame. So as you can see, this data now goes from 9:30 to 16 o'clock. So these are the regular trading hours. If we want to change that, we need to pass the respective parameters. So start time needs to be equal to, in our case, since we're interested in the entire day, 000000, then a comma, copy that, and set end time to be equal to 23:59. Now, since we actually have the granularity of 1 minute, that is not going to matter too much here, the seconds part. But if I run this now and look at the data frame, now you can see the timestamps are going from 0000 to 23:59:00. Now, as I already mentioned, there is a problem here with stock options. We don't have any data outside of the regular trading hours, so all the volume that we have is going to be between 9:30 and 16 o'clock. If we want to have extended hours trading volume, we have to look at indexes. So I can go here and swap the symbol from Apple to be SPX, which stands for the S&P 500, which is 500 American companies. By the way, let me remove the comments here so it looks a little bit cleaner. But this is basically the S&P 500 data, and now we're going to see this new data frame. I don't think that we're going to necessarily see volume every time, but now we do have the possibility of volume being there outside of the trading hours, outside of the regular trading hours. So let us actually write a function now that gets us this extended hours trading volume. I'm going to call this get extended hours volume, and this is going to take now ticker, date, and expiration as parameters. Now, in order for this to work, I also want to turn this here into a Python function. So I'm actually going to say here def get OHCL data, and I'm going to pass ticker, date, and expiration. By the way, here as a disclaimer, none of this is financial advice, and I'm also not really a financial professional, so I know to some degree what I'm talking about. But when it gets to the details, I might get stuff wrong. This is mainly a programming tutorial. It's mainly targeted towards people that want to understand the programming side, the pandas side, the data analysis side, not so much the finance side. So I'm not going to teach you stock options here or how to analyze them in terms of the actual economics knowledge. I'm going to only teach you how to do the analysis work in Python, so the programming part. Just so you don't get confused here if I get something wrong in terms of the economics part. So let us swap the date here for the date parameter. Let us swap the symbol for the actual ticker, and let us swap the expiration date for the expiration passed. This is necessary because we're going to use this function in order to use this function. So we're going to define this function by calling this function, but doing some stuff around it too. So the first thing we want to do is we want to get this data frame. So we're going to call this get OHCL data with the same parameters. That is going to give us this data frame that we have up here if we pass SPX and the respective parameters. And then I'm interested in the time, not the full timestamp, not the date, just the time itself. And I can get this easily by saying df time is equal to df timestamp, and to this now I want to apply a function which is going to be a lambda expression. Given a timestamp x, what I want to do is I want to say dt datetime from, what was the function called, ISO format x. So turn this into a datetime object and give me just the time. And now it's important to understand what we're trying to do here. So this function get extended hours volume should return to us the entire trading volume, all of the trading volume that happened before 9:30 and after 16 o'clock. Now, maybe we also want to differentiate between put volume and call volume, but we definitely need to aggregate this data. So maybe to make this easier to understand, let us take a look at what the data frame looks like right now. For this, I'm going to return it here. And I think I also need to return it here at the top because otherwise we get none. Return data frame and down here as well. And then we can just call this on the default values that we had before. So SPX, and here now we had this date in the default example, and then it was 2025-1/17. So that should show us now that we have a new column, and this new column is time. So here we have the timestamp, here we have just the time. But you can see that for every different strike price, we have the timestamp. So we have for every write and strike price, the whole time span on a minute by minute basis. We don't want to have that. So what we want to do is we want to group. We want to say df group by, and the columns I want to group by is the ones that I want to differentiate. So I want to have actually different entries for each time and also for each write. And the only thing I want to aggregate is the volume. So I'm going to say here, actually need to pass this as a dictionary. I'm going to say here the volume should be summed up. And of course I need to also assign this, otherwise it doesn't work. But now if we take a look at this, you're going to see it's not exactly the format that we like, the format that we expect. So what we also want to do is we want to reset the index, df reset index, to make this look like a normal data frame again. And there you go. Now we have for each timestamp the call volume and the put volume. But this of course also includes the regular trading hours. So we need to filter for only time frames that are outside of the regular trading hours. So this is super simple now. In order to get the call volume, all I have to do is I have to get this data frame, and I'm only interested in the sections or the rows where the write is equal to call. But another condition is I'm also only interested in those where the time is before 9:30 or after 16. So actually I need to use two brackets here. So the time has to be less than dt.time and then 9 o'clock, or actually 9:30, or, and here now I need to close the first bracket, or the time is greater than dt times 16:00. And now this here is in brackets, this is now in brackets too, and I need one more closing bracket. So this is going to give us all the rows where the write is call and where the time is outside the regular trading hours for those who want to get the volume and who want to sum up the entire volume. So that is going to give us the sum of the call volumes, and then we do the same thing for put. It's going to look like this, and then we just have to say total volume is going to be equal to call volume plus put volume. And then we can just return the three values. We can say call volume, put volume, and total volume. And when I run this, I get 3 integers. So in this case, on this specific date, for this specific expiration, for the S&P 500, we had a total volume of 2,087. So that is the number of trades outside the regular trading hours. All right. And now again, what do we want to do with this? What we actually want to have is for every single day of a year, we're going to focus on 2024 now. So for 2024, 1st of January, which is not going to be a trading day, but for every day up until the last day, which is 2024, December 31st, every trading day in between, what I want to have is the total volume outside of regular hours. And then with this data, what I want to do is I want to find the outliers. Where do I have the 95th percentile data? So where do I have unusual spikes of volume outside of the trading hours? Now for this, we need two things. One is a function that determines whether a given day is a trading day or not. And the second is the expiration dates that we want to focus on. Again, I'm not a financial expert, but what I think makes sense here is we're going to go for the third Friday of each month. This is basically the standard monthly expiration date. So what we're going to do here is for every date, we're just going to get the next standard monthly expiration date to analyze the volume. Now, conveniently, there is an endpoint here in theta data, which gives us the information. I think it's under calendar. For a single day on date, it tells us whether this day is a trading day or not. So we can just copy the code here again. We can paste it. And if I just run this without doing anything, you can see it's type open. So it gives us the opening and closing hours, and it tells us that the market is open on this particular date. If I change this, for example, to 1st of January, then it tells me full close. So again, we can turn this into a function. I'm going to call this is options trading day. I'm going to get a date as input, and then I'm going to just indent this. The parameter is going to be the date. I'm going to remove the comments again. Then we're also going to replace this streaming with a client again, timeout 60 as client. And then we're just going to do a simple get request. Response is equal to client, get the URL with the parameters. I'm going to raise for status. And no need to turn this into a pandas data frame. We're just going to get the JSON object and check if the type is open or early close. So I'm going to return here, response, JSON, type, first element is in. And now I want to have a tuple here. It's either going to be open or early close. So that is always going to return true or false for a given date. So I can try now is options trading day, and I can pass again 2024 1st of January. It's going to give me an error. Okay, why? Because I have to specify that the format I want to have now is JSON, since I'm expecting JSON. So format here in parameters is also going to be JSON. But now when I run this, I get false. And if I go and try this for the 2nd of January, I get true. And if I try this for the 5th, I get true. But if I try this for the 6th, I think 6th is now Saturday, there you go, false. So this function works. Now what we also want to have is the relevant expiration dates. So I hard-coded this. This is just the 3rd Friday of each month. So the 19th of January is the 3rd Friday in January. The 16th of February is the 3rd Friday in February, and so on. So these are the expiration dates that we're going to focus on. And now we just need some code that can go through every single day that is a trading day and record the trading volume. So I'm going to define the time frame. I'm going to say start date is equal to DT date, and I'm going to start here with 2024 1st of January. I'm going to go up until the very end, which is the 31st of December. And the delta, the step, so to say, is going to be DT time delta days is equal to 1. So we're going to jump by 1 day. Then I'm going to fill up a list that I'm going to call data, and I'm going to say while the start date is less than, oh, actually I need to call this end date. So while this is the case that the start date is less or equal to the end date, I'm going to increase the start date by 1, and I'm going to check if this particular date is an option trading date. So if is options trading day, then I'm going to say that we're going to do the calculation. So our function for calculating the volume expects an expiration date. And we do already have the expiration dates in here in this list, but we need to calculate which one is the correct one to use. So we're going to say next expiration is going to be equal to, and now we're going to just go with the smallest one that is after the date that we have. So expiration date for expiration date in relevant expirations if this expiration date is greater than start date.iso format. So that is just always going to go with the closest date that is in the future. Then the volume is what we get from our function. Call volume, put volume, total volume is equal to get extended hours volume for the given date. So for the start date, for the next expiration that we chose, and the ticker symbol is going to be SPX. We're just going to do this for the S&P 500 here. That is going to be the volume. And now we just need to append this to the data as a dictionary, because we're going to turn this into a pandas data frame, of course. So the date is going to be the start date, and then we want to have the volume. So call volume will be call volume, and then we can copy this and change this to put, change this to put as well, change this to total, change this to total. And to see what's happening, we can say print processed, and we're gonna write down the date so we can see the progress. And of course, I'm not just saying plus equal 1, I'm saying plus equal delta. That is why we created it. But now we can just wait, and this is going to calculate, or this is going to get the information, calculate the information for every single day of 2024, that is a trading day. But of course, you need to be careful and make sure all of this is indented, because otherwise it's going to run this every time, also for non-trading days, and then we're going to get an exception. So run this again with the code indented. And once this is done, we can easily just take it and turn it into a pandas data frame. So I can just say data underscore df is equal to pd data frame, and then I can pass data here, which is the list with the dictionaries. And by doing that, I now have a pandas data frame that contains the call volume, put volume, and total volume for every single date here. That is trading day. Now to save the progress and not have to run through all this again, we can save it as a CSV. So I can say datadf.toCSV, and I can just say, for example, volume data.csv. So now the actual detection of unusually high trading volume is not that difficult, because we can work with the quantile function. So we can get the 95th percentile of data by saying datadf.totalvolume.quantile, and then I can pass 0.95. This is going to give me the threshold, so to say. And then if I'm interested in only the days where the volume is above this threshold, I can say datadf, where the datadf.total volume is greater than this threshold. So this is going to only give me the days where the total volume is in the 95th percentile. Now you might argue that this is not a very good approach because we're basing this quantile on the entire time frame, whereas here we're just considering a specific day in the middle of the year. So if we want to make this more professional, what we can do is we can use the expanding function. So I can create a new field in my data df, which I can call total volume and then Q95. And then I can just say this is equal to data df total volume, and then I can call the expanding function, and then I can call the quantile function onto the results. And then I can just take a look at it. What does the data frame look like right now? Here I have the quantile up until this particular point. And then I can do the same filtering as before, but this time I'm not going to do the quantile across the entire time frame. I'm going to do it with this new column. So I'm going to say where it's actually higher than the Q95 of this particular row, like this. And now I'm getting this data here. Now, this is where the stuff gets a little bit more complicated because now we're getting into finance territory. Analyzing what this actually means is nothing that I would consider myself an expert in. So I cannot really tell you why this was the case now. One thing that I do notice, however, is this particular date here occurs quite often when you do different sorts of analyses. And it seems to be related to this event here, which is the Japan crash or Japan shock. So potentially this is the reason why people were trading that much in an unusual way outside of the regular trading hours. Then I also had 21st of November, which could be correlated with the Nvidia results or with the Nvidia earnings. So yeah, the analysis, I leave that up to you guys, but this is something that you can look at to correlate this with events, especially if you're doing this in real time for the current data, because of course the same algorithm, the same analysis, the same approach can be used for today if it's a trading day. And if you notice something unusual, maybe you can correlate this to something that you can read on the news. Now, looking at these tables is fine, but what I prefer is visualization. So let us go ahead now and plot this data using Matplotlib. For this, we're going to start by choosing a style. So plt style.use, and I think the one that I want to use is called BMH. That is it. And what I want to plot now is a bar chart where we can see the volume over time, but I also want to plot the moving average, a simple moving average, 30-day simple moving average. And I also want to highlight the days that are expiration dates. So I'm going to say here data df, and I'm going to define a column called SMA30. This is going to only focus on the total volume. By the way, of course, you can do everything we do here with put volume and call volume if you want to differentiate there. So you have the columns here in the data frame. But essentially what I want to do now is I want to say, give me the total volume. Then we're going to use the rolling function. We're going to define a window of 30. So this is going to aggregate the last 30 days, and we're going to take the mean. So of course, for the first 30 days, we're not going to have any data, but then we're going to have the 30-day moving average, simple moving average. And then I also want to have a column called bar color, which is going to determine the color of the bar we plot, and it's going to be different if the day is an expiration date. So that's going to be quite simple. Remember, we have the date column here. All I'm going to do is I'm going to say data df.date, and I'm going to apply here a lambda expression, and the lambda expression is basically going to return a color code. If something is the case, I'm going to decide on the color code in a second here. But if this date that we're looking at, if it's part of the expiration dates, or I call this relevant expirations, then we're going to do this color. Otherwise, we're going to do a different color. And the colors I want to use are FF6666. So this is going to be red, and this here is going to be 00AAFF. So it's going to be a greenish blue. So now we can take a look at the data frame to see what it looks like. We now have the bar color for the individual days, and we have the simple moving average focusing on the last 30 days. Now the plot itself, we're going to create a figure, PLT figure. The figure size is going to be equal to 16:8. Maybe we have to change that depending on what it looks like. Then I'm going to do a bar plot as mentioned. The first one here is going to be the X values. The X values are going to be range, length, data, df. So it's just going to be a data point for every single row in the data frame. And what we're plotting is the total volume. So data df total volume, and the color of the individual bars is going to be determined by data df dot bar color. So this already should give us a visualization, but I want to do some more stuff here. So there you go. Okay, so there seems to be a problem with the bar color. It doesn't seem to turn red at all. Let me analyze the values that we have here for bar color. No, it's always the same. So something doesn't work with this check. Okay, so maybe because we have date objects in here, so we could be probably able to fix this by saying .iso format. Yeah, now it works. So let's now replot this. Now you can see we have red bars for all the expiration dates. What you can see already is that we get exceptionally high trading volume right before these expiration dates. So all these dates that are very close to the expiration dates probably are not that meaningful. Again, none of this financial advice, just my interpretation of this. So the interesting days are actually those where we have spikes without having an expiration date shortly after. So here, for example, this one or this one. These seem to be actually interesting dates. But now let us refine our graph. First of all, we need to plot the simple moving average. So PLT plot data df SMA 30. And the color for this is just going to be purple. There you go. Now we can see the simple moving average here. But as you can see, we're just getting numbers here and I want to get the actual dates. But of course, I don't want to plot all the dates because then I'm not going to be able to read them. So we're going to define a step size. I'm going to say here step is equal to 5. We can change that later on. Indices are going to be equal to range starting at 0, going to the length of the data frame, and having a step size of 5, or step to be able to change this easily with the variable above. And now we just need to get the x values by getting the dates with these indices. So we're going to say PLT xticks is going to be indices, and then data df date ilog indices. And we're going to also rotate. So rotation, I think, is the keyword 45 degrees. So now you can see we get the dates down here, and I can also, if this is too much for me, first of all, I don't want to have all this output, so I'm going to say PLT show, and maybe I want to change this to 10. That looks a little bit better. So yeah, that is one thing that we can take a look at. As you can see here, the 7th of August is this date. So this here is the 5th of August. This is the spike that we had from the Japan crash. This is very high trading volume without being close to an expiration date. So this seems to be an actually special event. Again, just my interpretation here. But now what I would also like to do is I would like to plot call and put volumes separately. And I would like to do that in a fancy way by having them overlaid, but not stacked, not just putting them one on top of the other, but having them as the same bar, but the higher one appears from the background. Now for this, we need to do some pre-processing and some calculations because we need to know when do I put the call bar in front of the put bar and when do I do it the other way around. So if I have higher call volume than put volume, I want to put the call bar behind the put bar, and the other way around if the put bar is the higher one. The one that has more volume has to be in the back. So what I'm going to do now is I'm going to say data df, and I'm going to call this field now put back is going to be equal to data df apply onto the whole data frame, a lambda expression. So this is now not onto a single column. We're applying this onto the entire data frame. And I'm going to say if the put price or put volume, sorry, is greater than the call volume. And actually, I don't need an if because we're just going to return the truth value here. Then we're going to put it back. And this has to happen on axis 1 because we're comparing columns. So now this gives us for every day which one is higher. So in this case now, the put volume has to be in front of the call volume because the call volume exceeds the put volume. So this is false. Here it's the other way around, so this is true. So now let us generate x values, and since we want to do some fancy operations, we're going to do that with NumPy. X is going to be equal to NP a range, length of the data frame. Then I'm going to create another figure. Figure size is going to be the same, 16:8. And now I want to plot all the bars where the put has to be behind the call. So I need to plot the put first. So how do I do that? I say plt.bar x. And now, since this is a NumPy array, I can do that here with truth values. I can say x, where data df dot put back is true. So give me all these indices. And then what I want to plot actually is from data df, the put volume at the same positions. So data df put back. So what does that mean? I want to plot all the put bars, but only there where the put volume is larger than the call volume, because then I want to put it in the background, which means I'm going to plot the call bar on top of that. And since this is put, I'm going to say the color is going to be red. Now I can copy this and I can do the same thing here with the truth values, just the call volume as the second one. So we can still keep put back here because that's the same condition. We just plot the call volume afterwards. And the color here is going to be green. And now I can just copy this, paste it down below, negate the whole condition. So where this is not the case, I just use this wave symbol here to say where this is not the case, we're going to do it the other way around. I'm going to plot call first. So first call and then put. Now for the rest, we can copy this from above. That's not going to be different. We're just going to have the same xticks. And now we can see that I have this fancy plot with the call volume and the put volume. If the call volume exceeds the put volume, it looks like this. I have the green on top of the red. Otherwise, it's going to be flipped. And as you can see, when it comes to indices, to options on indices, we can see that put is usually what people do. So the put volume exceeds the call volume most of the time. This is not the case for stock options. There it's flipped, but here that is the case. Now, if we want to, we can also go ahead and plot the simple moving average for these two values. So I'm going to say here SMA 30 put is going to be equal to DF put volume. Actually, it's not DF, sorry, data DF, and then data DF put volume. Again, rolling window 30 mean. And then I can copy that, do the same thing for call. And then I can just go and plot the same line as above. So I can copy this, do it twice, then replace this by put and call. Then we can go and make this red and this one green. Probably we should use different color codes because that's not going to look very good. So let us go ahead and do FFAACC here for a bright red and 88FF99 for the green. And there you go. Now we can see the moving averages here as well. Okay, so now we get to part 2 of this video. Now we're going to compare the full volume of the day, including the regular trading hours, to the open interest. So we're going to calculate a ratio, and the open interest is the number of contracts that are still out there. So what I'm going to do for this is I'm going to scroll up and I'm going to slightly modify the function that we have here for calculating the volume. We're just going to remove the time constraint. So I'm going to copy this. I'm going to go down to the very bottom, and I'm going to replace this here by saying get full volume, and I'm going to just remove the time constraint. So the only constraint is going to be that the right has to be call and that the right has to be put. Then we also need a function to get the open interest, and Bright Data does have such an endpoint. It's called down here the open interest endpoint. We can copy the code for this endpoint and turn it into a function again. So I'm going to just paste this, and if I run this, you can see we get streamed data here with open interest. Now what I'm going to do is I'm going to remove the imports. I'm going to remove all the comments. Then I'm going to call this get open interest data, ticker, date, and expiration again. We're going to replace these down here. So the date is going to be the date, the symbol is going to be ticker, and the expiration is going to be the expiration. And we're going to indent all of this again. And then I'm also going to replace this here again by HTTPX client timeout equals 60 as client. Then response is going to be equal to client get the URL, and the params are going to be the params. And then finally, we're going to say again, data frame is equal to PD read CSV on the response text. But of course, we need to do string IO first, IO string IO response text, and that's basically that. So we can call this again, get open interest data on SPX. And then we had also 2024, what was it, 11/7. Then we had 2025, January 17th. That is going to give us a data frame, which of course we have to return to see it. And here we have the open interest. So now we're going to do the same thing that we did before. We had the data function, which is this here. And now we're going to also, or actually we can use the function that we have down here. We're just going to aggregate in a different way. So I'm going to say here, or actually we're not going to even aggregate in a different way. We're just going to change what is being aggregated. We're going to say here, get open interest data. And the only thing we need to swap here is volume. So we need to change with a substitution. I'm going to change here volume to be open. I'm just going to call it open. I'm going to add an S here. So it's going to be calls open, puts open. And then of course here we cannot just leave open. We have to say open interest for the column name. But besides that, also I need to change it here, and then we should be done with that. This should give us the open interest. Of course, don't call this full volume, call this get open interest. And now we should probably run all of this again. And these are now the 3 functions that we have. So then all we have to do is we have to go up to the code that produced the whole data here. And we're going to do the same thing now for the open interest and the full volume. So I'm going to paste this. I'm going to call this one data2 here. And now I'm just going to say that this is going to be the same volume, just that this time we're going to use the full volume. Then I'm going to copy this and we're going to say calls open, puts open, and total open are going to be equal to get open interest. Then I'm going to copy and paste these 3 here. I'm going to swap volume for open again, and I'm going to say calls open, puts open, puts open, calls open, and we're going to append this to data2. That's basically it. This should work now. We do have a problem here. What is that? Volume does not exist. I forgot to remove volume here. Of course, this needs to be open interest as well. Now, maybe it makes more sense to use mean here, but I'll leave that up to you finance guys to determine if mean is a more reasonable thing here than sum. But now this is going to run, and we're going to wait for it to finish. Awesome. And now once we're done with all of this, we can turn this into a data frame again. I can say data2df is equal to pandas data frame and then data2. Then I can take a look at it and we can see we have here total open, total volume. And now I could calculate a ratio. I could say data2df and then I could say volume to open or something like this. And I could say data2df total volume divided by data2df total open. And then I could do the same analysis as before. I can say volume to open, or actually data2df, where this is actually larger than data2df volume to open, quantile 0.95. And then I would get these special dates here again, which are oftentimes going to be pretty close to the expiration dates. But we still have here the 5th of August. But again, I'm not going to comment too much here on the interpretation of all of this. I'm also not sure if the metric per se makes a lot of sense. What the goal of this video here is, and this is the most important part, is to teach you how to work with data and to teach you how you get data from an API here with theta data, with all these different endpoints, and how you can then manipulate this data, structure this data, visualize this data, and then you can take your own conclusions from that. If you are a finance person, that's not what I teach. I teach you how to work with data, and this is how you can do this with options data, with theta data. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, make sure to check out Theta Data, the sponsor of this video today. You will find a link to them in the description down below. And besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video and bye.